So we're back after having basically laid out the chassis for the circuit that we're going to put in it, which, as we said before, was the sock monkey, a simplified sock monkey circuit. So the way I did it, if you want a sort of like more in-depth explanation about laying out projects, you can look at the pedal board videos where we were making a loop box. But basically we used the same principle. We used some blue tape. We taped over the box all the way around so that we can draw on the box itself without drawing on the metal, which we obviously want to keep nice and neat. It also allows us, if we make a mistake or change our mind, to peel off tape or put more tape on top of it to make corrections in the layout. So we have all of our holes for the transformer, the 3 tube sockets, our 5 potentiometers, the IEC jack. We're going to be using an internal fuse. We've also got the input jack and output jack, which just about covers everything. So we're going to go right ahead and we're going to go and drill this out. As I've stated before, the easiest way for me that I found to do it is when you've got the tape on there, to take a scribe. This is a StuMac scribe, and just kind of poke through the tape, and that'll actually give enough of a depression or a divot for a 16th bit to kind of grab into and put your hole exactly, help you put your hole exactly where you want it. So I'm going to go ahead and drill this out, and then we'll be back. Oh, as a quick note, for installing the IEC power inlet, the AC power inlet, you notice it's kind of a D shape, or a weird kind of D shape to it, and you might be wondering, well, how do you do that without having a special tool, a multi-$100 to $1,000 punch custom tool made for you. The easiest way I've found to do it is to basically lay out where you want your square hole, which will accept this shape, and drill yourself 4 holes that are basically on the edges up to the edge of the outline of the perimeter of the hole. And then you can use a jigsaw to just go to the edge, turn around, go to the edge here, cut this way, then cut that way, cut this way, cut that way, cut this way, cut that way, and then you have a perfectly square hole without having to stress a lot. So that's the way I like to do it there. So I'm going to go ahead and cut all this stuff out, and then I'll be back. Okay, so we're back. We just finished drilling out all the holes for the various components. I've mounted a couple as we still have a few holes left to drill that are basically determined by the position of some of the components that are already there. So we have our potentiometer holes, obviously the 5 of those. We've got our 3 socket holes for our 9 pins for our preamp tubes, and we've got our transformer to be mounted here. We've got our IEC connector and our fuse holder. So the next step is going to be going inside of the amplifier, or inside the chassis, and we're going to start determining where we want components to sort of be laid out. So the first thing that I would do is, that I'm going to do, and I recommend doing, is to do your power supply first. Now your power supply is basically what gives your B+ supply to power your preamp tubes. And that is a DC supply, and our transformer obviously is going to be supplying AC, so we need to convert that AC signal into a DC signal, and we need to filter it. And to do so, we need basically 2, let's say, groups of parts. We need diodes, and we need capacitors and resistors. The capacitor RC network, we'll consider that 1 for the purposes of this. So we have here selected our capacitors for the entire circuit, and we're using 4 capacitors to supply. One is just a primary filter, and then we're going to use 3 additional capacitors to power 1 for each tube, 1 for each ECC83. What I've selected for that purpose are these radial can capacitors, which are a 47 microfarad 500 volt snap-in can capacitor. Now they're called snap-in because they have these little sort of legs on the end that have a little curve to them that when you put them in a properly lead-spaced arrangement, they kind of hold their place. And as it turns out, these terminal strips that you can get from like CE Distribution, they have the right spacing for these capacitors. So we can build ourselves our little power supply with 3 of these. So basically you take your capacitors and you just kind of insert them into the holes at the bottom of these tabs right here, so you can solder them in then. And then you have these tabs on top to attach any resistors or any wires to come out from this network that you need to do. So it's really handy. Now we're using 2 of them. So we're going to fit them in the chassis, and we want to fit them obviously further away from any audio paths. So we're going to try to put them as close as we can to the edge here. And that's why we want all of these components that would be there sort of there, so we can know that there's not going to be a problem with them interfering with one another. So what we're going to do is we're going to place these here, and that looks like it's probably a good spot for them right around there. And then the second part, obviously, of the power supply that you need is the rectifiers, the diodes. And for this project, I'm using these 1N5408, which are a fast-acting diode, which I've used in all the 3Monkeys amps, and I really like the way they perform. So we're going to use them in this. And what we've got is another terminal strip on which we're going to build the rectifier to supply these capacitors. Now, here's our transformer, and as you notice, you've got the 2 greens on the secondary side. This is the primary side, obviously, where you have your AC voltage come in, a common and a 120 volt. On the secondary side, we have our 6.3s, which are for our heaters, as well as 2 red, which are the high volt, which will supply the AC to be rectified for our B+. And you notice that there are only 2, so we don't have a center tap. So that being the case, we need to make what's called a full wave bridge rectifier. And well, I could show you, I guess. What a full wave is, basically, is 4 diodes to create a basically an artificial center tap. So let's say we have our power transformer here. You have your primary, your 0, and your 120, let's say, and over here you have your high volt and your other high volt. Okay. Now, normally, or not normally, but on a lot of amplifiers, you'll have a 3rd wire that comes out, which is equally distantly spaced between the winds of the 2 high volts, and that's called the center tap, as it's in the center. And what that does is give a ground reference point for the 2 high volts to attach to. And that would normally, if you had a high volt center tap, you would just ground that at a point in the chassis, and then you would have a point at which to develop your voltage potential. If you don't have a center tap, you have to build what we just said, which is a full wave rectifier. Now what that is basically is 4 diodes, and it's in a kind of like a diamond pattern. You've probably seen these maybe in Marshall pictures. They were very common in Marshalls as well. You've got, let's say, 4 points here. I'll draw that out for you. And you have your diodes, and their orientation is done all towards 1 point, right? And that we consider an anode and a cathode, and then 2 entry points for your AC. So what you would do is you'd connect one of your high volts to this entry point and your other high volt to that entry point. Then you would have a ground. This would become your ground, at which you would have a reference point for your anode. All right, so it would be, this voltage would be the potential off of this ground. So we're going to go ahead and move that out. So that's your B+, right? That's the positive. This is your negative. Now, you would also attach a capacitor here, right? In our case, this is a 47. And these points will be joined as the capacitor needs its ground at the same point that its positive voltage is generated from. In this case, in our amp, we've got, I should just draw the whole thing out for you. We've got 3 other capacitors. So we can do 2 and 3, and 1 and 2 and 3. And we got this guy. Okay, and these are also 47s. Now we're going to attach them all together by what's called a dropping resistor. For this, we're probably going to use a 10K here, and then we'll probably just use a 1K and another 1K. Okay. Now, in terms of, should also talk while we got this out about grounding. So when you've got a chassis, you obviously have ground points in it, and we've got an IEC type modern voltage inlet. You know, you've got 3 wires, right? You have your common, your hot wire, and your ground wire. So basically, let's just put these here, right? So let's say this is your 120, this is your 0 common, and this right here is your ground. What was that? Anyway, so we've got that. Now your ground point here is considered like your master ground. And that is the place where it actually will leave the chassis and go through your power cord and be grounded at your house ground. So I consider that to be, let's say, if the ground stream is considered kind of like a sewer pipe, which is a good kind of way of explaining it, as these capacitors filter out hash out of the DC supply, and that's really garbage that we just want to get out of the house, so to speak, into the sewer line. This would be the main line there. Now, when you organize a house, maybe it's done this way, maybe it's not, but in this house, we want our dirtiest lines to be closest to our main outlet and our main sewer point, right? That's heading out to the street. So when I arrange the grounding scheme inside the amplifier itself, what I like to do is I like to make the dirtiest grounds close to the IEC's ground, and then take our preamp grounds from our capacitors, which are, I call them preamp grounds, as they supply the DC voltage for the preamps for the, you know, the first gain stage and the 2 cathode followers that we're going to be using, and ground those at a point away from that, the furthest point away in the chassis from that. And that allows for quieter operation, as things like the cathode and the cathodes, the resistors, and the capacitors can actually pick up that kind of a dirty signal. Now, a lot of people use what's called a star ground and just ground everything at one point, but I like to separate them out a little bit and create a little bit of a variance in distance in the chassis between the two. And that's just my theory of operation for creating a quiet amp, and it served me well, so that's sort of what I do. So in this case, these 3 capacitors I'm going to sort of join in terms of their distance, or their point, their grounding point, and their distance from the major ground point. Tie them all together, and I'm probably going to ground them up here at this first potentiometer. So that should give us a really quiet operation. So anyway, getting back to the actual physical layout of everything. So we need a place to put in that full wave rectifier, right? So we've got another terminal strip in which we can build a full wave rectifier onto, stringing the diodes together. And what I figured I like to do is I'm going to put it actually between the 2 capacitor networks here. So it creates a nice sort of, you know, a good space in there, and we're not wasting a whole lot of room, and there really isn't a whole lot of room to stick it somewhere else. So in the middle is very convenient. The high volts can come up through the bottom, attached to the points right here, to the diodes, and then the diodes are in a perfect place to go out to the first capacitor, and then we can, you know, put our resistors in to go to second, to third, to fourth, and ground everything as we need to be grounded through the chassis. So this looks like it'll all fit pretty good. So what I'd want to do is I'd want to kind of hold this in place, take it out, right, and then mark where this centerpiece is, this strip, and that'll be our keystone. I've already done that, and I've drilled our little hole there. So that's sort of our keystone as to where it's going to determine the position of these, because we want it in the middle, right? So what I'm going to go ahead and do then is I'm going to build out the full wave bridge onto this terminal strip, mount it to the chassis, and then I'm going to place these 2 capacitor networks in to the chassis and mark where they fit nicely. And that way we know everything's going to fit together. So I'm going to go ahead and build this up and mark it out and drill it, and then I'll see you guys later. Okay, so We've got our bridge rectifier unit all built out on this strip here. And now we're just going to secure it to the chassis temporarily right now. Got our anode wire here, and that nut right there is the ground point as well for the rectifier. Okay, so now we need to position the capacitors. So we're just going to place them in here, and you can see why we did what we did first, because this determines quite, quite apparently where you're going to end up putting the capacitors at. So now I'm going to cut myself a couple of pieces of the blue tape so I can mark where I want my holes for what will be the standoffs for holding these capacitor networks down to the chassis. Okay, so we'll get them in a good spot again. And I like it like that. I think that's good. Just marking it with a pen. Okay, so we've got those marked now, and then we'll go ahead and drill those out. So I'm going to do that, and then we'll show you how we can do like some standoffs. Okay, so we've drilled out our holes for what we're going to make a standoff, basically a makeshift standoff. Now usually a standoff would be made out of aluminum, and it would be something like this. It's a little spacer that has it's threaded through a lot, and that'll allow you to mount something to a chassis sort of off the deck. But there's a lot of ways of doing this. In this case, I'm just going to use some number 8 screws and nuts, and I'm going to double up the nut. So we put one nut down, put our second nut down, but actually it sits a little bit high off the deck. If you can kind of see where the bottom of the capacitor is, which is here, there is about, well, it looks like about a 1/4 inch of space that we have to fill up. So we can measure and see. Yeah, that looks pretty good. So 2 nuts on a number 8 look like the trick to bring our standoff, or to make a standoff that's of the appropriate height to accept our network. So we'll have 2 like that, as you can see, and then we can just mount these guys on it, right? And then secure each side with a nut, right? This one can be a little tricky to get to if you don't have a tiny fingers. I got dexterous hands, but not enough to get in there. So I'll just use a pair of needle nose and grab my nut and just help it along. And there we go. Okay, so there we have our power supply ready to go. So it's just a matter now of mounting a few other, or deciding where a few other components are going to be placed. For instance, let's say the output jack. I'm of the opinion that I want to put the output jack, and I'm going to use one of these small little guys here, which are, again, going from Office Space. These are the, well, we know what they're called. So anyway, this guy, I think we're going to have located right here, right? So now that we know where our capacitors are going to be, where our potentiometer is going to be, and this will be actually the level for the output of the whole unit. So literally off this pot to this jack, so that's a really good spot for it. So we're going to go ahead and mark and mount there as well. And we're also going to need, obviously, a lot of resistors and capacitors to complete the circuit for these 3 tubes. And what I plan on doing basically is using the same sort of system where I'm using, let's say we mount our little guy here, our socket. Let me grab got a little dish of just random screws that I keep around, and I'll just show you what we're going to do. So we're going to mount these sockets with a number 4 1/2-inch screw, which will give us a little bit of thread to work with, and then we're going to mount our standoffs actually on the socket, and then we'll mount components going for the socket to the strip, and from the strip to the potentiometers, and back and forth for our first preamp stage, our cathode follower, which will be our tone stack, all like a top boost AC30, and then a cathode follower, which I like to use because it's a low impedance sort of dealio that we can drive, you know, the Two Notes cab M with quite nicely, and it'll simulate sort of the phase inverter. It's a lot of the, you know, the character of let's say an AC30 or a Marshall. If you just go from, you know, your gain stage to your cathode follower out, you're really going to miss some of the crunch of the phase inverter and the power amp. So I find that, you know, we can make up for that somewhat with a cathode follower, and then give a nice low impedance sort of signal to whatever we've got following this, which, you know, in some cases you may want to put, you know, delays in other cases if you're not using a Two Notes. But in my case, I'm going to be using the Two Notes. We're going to feed it a low impedance source, and then we're going to go out to that rig that I was talking about. So in any case, I think that's good enough for today. And I know we got a lot of projects going on here in the kitchen. They're fun to do, but that's how we like to spend our weekends. So I'm going to take a break, and I'll speak to you guys later.